Welcome to the second movie of the first paragraph, and it is about forces again, but now about gravity. So we're going to talk about the magnitude, how strong gravity is, and the center of gravity or the point of application of gravity. And I will illustrate it with drawing the force due to gravity on candies while C is 63 kilograms. Well, gravity, what are the magnitudes? What can we say about how strong it is? Well, first of all, you then need to measure it. You could measure it with a dynamometer, and this thing, it has a helical spring, and it has an extension. It becomes longer, and the longer it gets, the more force there is. And you can see one over here. And if we do that, then we can see, if we measure it, that the force due to gravity depends on the mass and basically how strong the Earth is. And if we put that into a formula, we get the following formula. That is that we have a force due to gravity is equal to the mass, is small m, and the g, that is the gravitational field strength, or that is how strong the Earth attracts. What is what? So this is the force due to gravity. And the force due to gravity is in Newton, as all forces are. And Newton, if we have an abbreviation, it's a capital N. The small m is the mass, and the mass is a small m, is in kilogram. Mass is always in kilograms, and G is always 9.8 on Earth. So, and that's something you need to remember, that G is always 9.8. Okay, and if we then want to calculate how large the force due to gravity is of candies, we simply need to use the formula. So then we have that the force of gravity is equal to the mass multiplied by g, that is equal to 63 multiplied by 9.8, and that is equal to, grab your calculator, 617.4, and then we need a unit, and the unit is newtons. So roughly 600 newtons, 617 or 610 newtons. And if we want to draw that, we need to know where the starts, and that's the center of gravity, and the direction, well, we know that's down, and then we need to know how long, and for that we need a force scale. Well, you can see it is just more than 600 newtons, and we want to get somewhere between 5 and 10 centimeters, so I propose a force scale of 1 centimeter corresponds to 100 newtons. Okay, we need to draw it, and in the tree position, this is the tree position with yoga, and well, we need to grab our geo, as you can see already put it, and then we need 6.17 centimeters, of course. You can't do it precisely, do it as good as you are able to, and then you are satisfied that this is the best you could do. And if you are within a few millimeters, it's fine. I don't care with that. I can't do that as well. So here we are, and the point is included. There we are. So this is the force of gravity. Okay, now you are able to basically draw the force of gravity and calculate the magnitude of the force of gravity, so how strong it is. But the point of application, or the center of gravity, it's yeah, strange, why is it over there? And you can see that it switches position if you have a different stance, if you are standing differently. So what is then the center of gravity? And that is something I want to talk about over here. The center of gravity, it has two things. First of all, the center of gravity is the average place of all masses. You can think of an object of having all kind of different masses, all kind of different atoms. And somewhere the average or the middle, but if you don't have a regular shaped object, it is not the middle. But yeah, and the average should be not taken literally, because if something is very, very far away from that center, it contributes more to it than other parts. That's the center of gravity. You can see over here on the top, if you have a regular shaped homogeneous object, homogeneous means that it is the same everywhere. Bijvoorbeeld, it's the same type of wood or aluminium, or if it's aluminium, it isn't part or two different materials or something like that. That's in the middle, and that's something you can see over here. But if it's irregularly shaped, what do you do then? Then you simply hold it on two places. One over here, you let it hang so it can rotate, and then the gravity will pull it downwards, and it will pull it downwards along the line on which the center of gravity is. So then you know that the center of gravity is somewhere on this line, this vertical line. And then you do the same with another point. You have already done it with this point over here, and then if you let it hang, then you will see that it is somewhere on this line, and then the intersection is where the center of gravity actually is. Well, the center of gravity is not only that place, it is also the point of application of gravity, where we draw it, where we think it is. Okay, that was it, and I'll see you next lesson. Bye.